Hello, and welcome to Calculus Lesson 110. Today we're going to talk about Rose curves. And this goes with your polar graphing scheme. So go ahead and change your calculators to polar mode, hit mode, then go down to polar, and then we'll begin. So the first thing we're going to graph is r equals sine of 2 theta. So these Rose curves are actually pretty easy. The thing you should know is that if it's an even power, you will get 2 times the amount of those petals, or if it's an even number here. So we'll get 4 petals out of the ones with 2, 4, 6, 8. If it's an odd number, like 3, 5, 7, you will only get that number of rose petals. So what does this look like? Well, the way we're going to solve this is I'm actually going to plug in angles and find the radius for each. So if I plug in 0, the radius is 0. If I plug in pi over 3, pi over 6, which is 30 degrees, times 2, that's pi over 3, so that's root 3 over 3. If I plug in pi over 4 times 2, that's pi over 2, which is 1, right? Sine of pi over 2 is 1. Sine of, let's see here, if I plug in pi over 3, I multiply that by 2 pi over 3, that is going to be, oh dear, friendly angles, oh, I lost it. It's over, just kidding. Root 3 over 3. And then if I plug in pi over 2 times 2, that's pi, so that's 0. So my first petal of the Rose curve, remember now you're thinking angle and radius rather than x and y. So I'm just zoom this guy out a little bit. If my angle is 0, so that's pointing in this direction, my radius is 0. So that's my first point. If my angle is pi over 6, so this is where a protractor can come in a little bit handy. Also, another way to do this is that you can actually split this into at least 45s so that you can see your angles a little bit better. So this would be angle 0, pi over 4, pi over 2, 3 pi over 4, pi, 4, 5 pi over 4, 3 pi over 2, 7 pi over 4. They also have little pages that actually have all the angles listed, and then you just go along those lines like we'll do here. 30 and 60 are closer to 45 than they are to 0. So if I wanted to include those as well, it would probably be somewhere around there. Like I said, it may be worthwhile for you to investigate, or at least print out, some graph paper for polar graphing. So what I've done is I've graphed 30, 45, 60, 90, and so on, just as lines. Now, my first point, 0, 0, is done right here. Along the 0 degree line, I go 0. Along the pi over 6 line, I want to go root 3 over 3. Now, it's really hard to estimate that. Root 3 over 3 is like 0.86. If you want to use like a ruler and measure it out and say, all right, cool, I'm going to go 0.86 of an inch, you could. That's going to give you a very small rose, but it is possible. Another option is you can just draw circles with your compass, and that will allow you to get a good range of these. Since this is just a sketch, I'm going to estimate this is 0.86, which is about that. Then 1 should be a little bit further, so I'll go about there. Then at pi over 3, I'm going to go root 3 over 3, so that's going to be back over here. Then at pi over 2, it's 0. So I'm back down here. So my first petal looks something like that. Now here's where it actually gets quite surprising. You would think it would do this petal next. But if I plug in, let's see, 4 pi over 6, or 2 pi over 3, that's what I want next, which is my next angle, which is 120 degrees, I actually get negative root 3 over 3. Because if I multiply this by 2, sine of 4 pi over 3 is negative root 3 over 3. Then I would do 3 pi over 4. Then I would do 5 pi over 6, and finally pi. What you'll find out is this is actually negative 1, negative root 3 over 3, and 0 again. So instead of going in the positive direction along this line, I'm going to go negative root 3 over 3, which means I'm actually going to come down here. Instead of going positive on the 3 pi over 4, I'm going to go negative. So it's going to be down here. And instead of going positive on the 5 pi over 6 line, I'm going to go negative root 3 over 3. So this curve goes up this way, it goes down this way. Then it's going to go again, let's find out. So my next angle would be 7 pi over 6. I multiply that by 2, I get 7 pi over 3, which is the same as pi over 3, which is root 3 over 3. So now that I go there, along this curve, I'm going to go root 3 over 3, so it actually does this one next. And then the last one is that one. Now, they should all look the same, and I'm not the best artist, but that's how you draw your rose curve, okay? So pick a couple of points, but after you do it, after you do the first one, you can kind of see which direction it's heading. So if it's heading down, it's probably gonna end up over here. If it's heading to the left, it's probably gonna end up, well, it's a little bit harder, but it does end up here and then goes up. You could just do this by finding the 45-degree angles, because you know it's going to have 4 petals, and it'll show you where it goes in each quadrant. Now, you can also plug this into your calculator, and that works perfectly fine as well. So if you want to, go in polar form, plug in sine of 2 theta, and you're set. They'll have you do that in your graphing calculator. Now, I could belabor this point more, but instead, I'm going to kick you off and hope you enjoy your lesson today. And enjoy some of these beautiful roses. Have a great day.